Hello guys, welcome back. In this video, we will learn about quadrilaterals and their general properties, types of quadrilaterals and their respective properties, and then we'll finally see about the regular hexagon and its properties. So let's get started. So we already saw that quadrilateral is a polygon having four sides. So a polygon has four sides and it also has four vertices. And what is the sum of interior angles? So for a n-sided quadrilateral, it's n minus 2 into 180 degree. So this is 4 side. So 4 minus 2 into 180 degree, which is 2 into 180 degree, which is 360 degree. Okay. And they also have two diagonals. This is one and this is the other. Okay. And if you have a quadrilateral, any quadrilateral, you can draw one diagonal. Say the length is d1, and if you draw the perpendiculars from the other two vertices to this diagonal, say h1 and h2, then you can see it's like two triangles, right? So the area of this quadrilateral will be half into d1 into h1 plus half into d1 into h2. So which is nothing but half into d1 into h1 plus h2. The other formula is, which can be proved using vectors. So if there are two diagonals d1 and d2 of length d1 and d2, and the angle is some theta between them, it can be this or this. So the area will be given by half into d1 into d2 into sine theta. Okay. So you can see this angle, let's say phi, is nothing but 180 degree minus theta. So sine phi is sine of 180 degree minus theta, which is equal to sine theta. Now we can also call this, write this like this, sine phi. So this you will be able to prove it from the vector analysis. Yeah. And suppose we have a quadrilateral inscribed in a circle. So we have circle and there is a quadrilateral inscribed in it. So this quadrilateral is called as a cyclic quadrilateral. So A, B, C, D. So inscribed meaning all the vertices are on the circle, on the same circle. Okay, so there is a special property of this. The sum of opposite sides is equal to 180 degree. So angle A plus angle C is equal to 180 degree, and angle B plus angle D is equal to 180 degree. So this is for the cyclic quadrilateral. Okay, then we'll go into types of quadrilateral. So the first type we'll see is a parallelogram. So as its name suggests, the opposite sides are parallel. So AB, CD. AB is parallel to CD, or let's say DC, to indicate same direction, and BC is parallel to AD. So by virtue of this parallelness, we also have AB equal to CD and AD equal to BC. So the opposite sides are also equal. So the area of this is given by base into the height. This is only applicable for a parallelogram. Base into height. Why is it so? Because if you draw this diagonal, you can see it's divided into two triangles of having same height h, and the base is also same. This is b and this is also b. So it is half into b into h and half into b into h, which together makes b into h. Again, area also can be seen from vector formula as the cross product between two of the adjacent sides. So which will give you half into dc into dA into sine theta. So the half will not be present, right? Because it's a parallelogram and not a triangle. Okay. So what is the perimeter for this? Perimeter is just the outer boundary. So if we take this as A, we have A plus B plus A plus B. So we have 2 into A plus B. So other properties of this parallelogram are if you draw the diagonals bisect each other. So this portion is equal to this portion and this is equal to this portion. So diagonals bisect each other. And we also have opposite angles are equal. So this angle is equal to this angle and this angle is equal to this angle, and the sum of adjacent angles is equal to 180 degree. So they are supplementary. So this angle plus this angle will give you 180 degree. Okay, so next we'll see about rectangle. Rectangle is a special form of parallelogram where the angles are 90 degree each. So still the opposite sides are parallel and they are equal, and all the angles are equal to 90 degree. So here also, let's say this is B and H. Area is equal to base into height. So all the properties of parallelogram also holds for rectangle, such that diagonals bisecting each other, right? And so here like automatically we know the sum of adjacent angle is 90 degree and opposite angles are equal. So we can also find the diagonals length, right? So using Pythagoras theorem, d square is equal to h square plus b square. So which will give you d is equal to root of h square plus b square. So it is also, we can also say that all rectangles are parallelogram. But converse is not true. So all parallelogram cannot be rectangle. For example, this is a parallelogram. So I'll take 60 degree, 120 degree, 120 degree and 60 degree. So this is a parallelogram. This cannot be a rectangle. Correct? Yeah. Okay. So next we'll see about rhombus. We can say rhombus is also a special type of parallelogram with all of its sides equal. So AA. So what will be its area? If we have height h, it will be A into h, correct? And so here again the opposite angles are equal, and we have one additional property that the diagonals bisect at right angles. So diagonals bisect at right angles. So we saw the area of area to be, so I think here we saw it, right? So this is the area. We know that angle phi is 90 degree for a rhombus. So the area is nothing but half into the product of diagonals. So the diagonals still, they may not be equal, but still they bisect each other. So all properties of parallelogram still hold for a rhombus. Okay, so next we will see a square. So square is also called as the regular quadrilateral. So we have all the sides and angles equal. If angles are equal, then they should be equal to 90 degree. So here the one side is A, all are A. So A itself is the height, right? So area is A square. And if we have diagonals, again this is some special kind of rhombus. So still they bisect at 90 degree. And area is also equal to half into, let's say, the diagonals. Here the diagonals are equal, D square. So diagonal is given by A square plus A square under root. So which is equal to root 2A or A root 2. And the perimeter is 4 times A, right? 4A. So here again the diagonals are equal and bisect each other. Again, all properties of parallelogram. So this is also representation of parallelogram, rectangle and rhombus hold. Okay. So next we'll see about trapezium. So in a trapezium, two of the sides are parallel to each other. Two sides are parallel to each other. So let's say A, B, C, D. And if you have this as the height h, so if we draw a diagonal, so you can see, let's say this length is L1 and this length is L2. So area of this triangle is half into L1 into H1, right? And area of this triangle is half into L2 into H2. So the total area is half into height into L1 plus L2. So it's half into height into sum of the parallel sides. So this will be the area of a trapezium. So one special property of a trapezium is, if you have the trapezium and if the non-parallel sides are equal, then the diagonals will also be equal. Diagonals are also equal. Okay. So we have another quadrilateral also, which is not very popular, which we call it as kite. Here the adjacent sides are equal, only like two pairs. So what I mean by this is, so this is equal to this and this is equal to this. So if we draw the diagonals for this, so they intersect at 90 degree. The diagonals intersect at right angle. So what will be the area of the kite then? It's half into d1 into d2 sine 90 degree, which is 1. So So if the one diagonal is d1, another diagonal is d2, it's given by half into d1 into d2. So we can also say, like, you can see this diagonal, right? It divides the kite into two isosceles triangle. One diagonal divides the kite into two isosceles triangle. And this diagonal is nothing but the shortest diagonal, right? So the shortest diagonal also we can see. Okay. So next we will see about a regular hexagon. So hexagon is six-sided polygon. Regular meaning all sides are equal and all angles are equal. So is it necessary for all angles also to be equal? Is it not sufficient for all sides to be equal? So I'll give you another example. So in this also all sides are equal, but this angle is greater and this angle is smaller, right? So it is not a regular hexagon. So it is necessary for all sides and all angles to be equal. Let's take the side as A. So let's draw, okay, I'll draw a bigger picture. So if we draw the diagonals 1, 2, 3. If we draw the three main diagonals just connecting the opposite corners, you can see there are also other diagonals, right? So E and C, so F and D, these are all other diagonals. But let's say the ones connecting the opposite sides are main diagonals, then you will see that the side length is A, and the interior angle of hexagon n minus 2 into 180 degree, so 4 into 180 degree, and each angle is, you will get divide by 6, you will get each angle. So 30 degree, it's 120 degree. So each angle is 120 degree. So this main diagonal will divide it into, it's like an angle bisector. So each angle will be 60 degree. Similarly for everything. So this forms a triangle if you see. So if two side angles are 60 degree, the third angle is also 60 degree, and it forms a equilateral triangle. So everything are equilateral triangle. So one hexagon can be divided into 1, 2, 3, 4, 5, 6 equilateral triangle. So if this side is A and these also form as A, right? So equilateral triangle, we know the area, root 3 by 4 A square. So we have 3 root 3 by 2 A square as the area of the hexagon. So this will be the area of hexagon. And if you see the longest diagonal, right, length of the longest diagonal is twice. So these all three are longest diagonals, so twice the side length. So 2 times A, twice the side length. So I think this much is enough to solve most of the problems on quadrilaterals and regular hexagon. So let's meet again in the next class. Thank you.